Good afternoon, ladies and gentlemen. Welcome to the first China and Russia Symposium on Artificial Intelligence and Quantum Computing. So my name is Joshua Huang. I'm the chair of this opening session. First, I want to check Professor Farid. Can you hear me? Okay, good. So we have some people in Russia online to listen to our symposium. First, let me introduce our distinguished guest today. Maybe we collect after I introduce all the names. The first, Professor Qingquan Li, the academician of, let's last together, otherwise it will last. Okay, good. Academician of Chinese Academy for Engineering and director of Guangming Lab, who is the host in this symposium. He is also general chair of today's symposium. Okay, second, I will continue after I complete and we clap, okay? Then Professor Sergei Goncharov, academician of Russia Academy of Sciences. Professor Sergei Potohov, academician of Russia Academy of Quality Problems. Professor George Tokonikov, academician of Russia Academy of Engineering, who is sit there, that's gentleman, okay. Then our guest in China, Professor Xu Lei, academician of European Academy of Sciences and the chair professor at Shanghai Jiao Tong University. We have a speaker, Professor Yi Pan, academician of European Academy of Science and Arts. He is also dean the Faculty of Computer Science and Control Engineering at the Shenzhen University of Advanced Technology. He had some meeting somewhere. He will come later to give his speech. And Professor Pan Wei-ke, the department head at the College of Computer Science and Software Engineering, Shenzhen University. Because we invite his supervisor to speak, but he has an urgent meeting today. So he sent Professor Pan to come to give the similar talk. The last, Professor Lingjie Zhang, our distinguished professor at the College of Computer Science and Software Engineering, Shenzhen University. Okay, let's welcome them. Okay, first item, let's first welcome Professor Qingquan Li to give an opening speech. Please.
Dear distinguished guests, ladies and gentlemen, good afternoon. Welcome to the first China-Russia Symposium on Artificial Intelligence and Quantum Computing. This symposium is organized by Guangdong Laboratory of Artificial Intelligence and Digital Economy, also called Guangming Lab, and supported by the Section of Systematical Approach and Artificial Intelligence of Russia Academy of Engineering. This is the first joint activities between Guangming Lab and the AI section of Russia Academy of Engineering. Guangming Lab is one of the 10 Guangdong laboratories established by the Guangdong province government. This lab carries out the whole chain of basic research technology development and technology and skill transfer, industrial applications, and startup incubation in artificial intelligence and digital economy. These focused R&D directions include domestic AI computing, power environment building, multimodal generative artificial intelligence, Special Intelligence and AI for Science. Today, in this symposium, we have invited the world-leading scientists from China and Russia to give talks on these topics and share their research results and views in the future development of these important areas. Shenzhen City is a leading hub for artificial intelligence in China. Our local government is aimed to build a pioneer city of artificial intelligence. As a new research institution strongly supported by the government, Guangming Lab is committed to gathering global research forces and focusing on breakthroughs in basic series, core algorithms, and devices, key systems, and advanced industrial applications related to artificial intelligence and digital economy. We are targeted at producing original research results and innovative technologies and systems with independent intellectual property rights. We are also committed to cooperation with leading enterprises in the Guangdong, Hong Kong, Macau, Great Bay Area. Serving the economic development of the Great Bay Area and building a base for the gathering and training of talent in artificial intelligence. Finally, I wish all of you will enjoy the talks given by our distinguished speakers and wish our Russia friends a good stay in Shenzhen. Thank you.
Very good welcome speech. I think now we have complete our short agenda of the opening session. Let's move to the first speech session. I'm also the chair of this session. So let me introduce our first speaker, Professor Sergei Goncharov. He's an academician of Russia Academy of Science, also head of a laboratory of computability theory and applied logic at the Sobolev Institute of Mathematics and Novosibirsk State University. He's also the former director of the Sobolev Institute of Mathematics in Russia Academy of Sciences. I say a little bit more, okay? Sergei Goncharov is an important figure or prominent scientist in mathematics in Russia and the world-recognized leader of modern mathematical logic. I know he has won a number of national scientific awards in both Soviet Union and Russia. He also co-authored more than 300 papers, also 12 books. He has a list of awards, as I remember from his resume. Professor Goncharov, welcome.
I would like to say at first, thank you very much for organization of this conference, and it's really a very important problem connected with artificial intelligence and some application in our modern society to use this method, and it's important and has very broad application. But nevertheless, now we have to understood the basis mathematical scientific problems connected with this new etap in our science and application of science for our society, the human society. And I would like to say thank you very much for invitation me here and to give this talk about some methodological and methods of mathematical method for trusted artificial intelligence, such that we need to have, okay. Okay. And first of all, what's the problem we have with application of this method? Such that we used some our knowledge about different data to construct some special program for different approaches in techniques and science and for control system. And for this reason, we need to know what we would like to do by this program and what this program will do. And it's really not so simple question. And I remember that when we started to do some computer science, the first program was did by command, and only on the base of mathematics, on the base of Gödel numeration theory. It was did the very big step. It was constructed some special programming languages in which we can write this program and to have some explainable for some block for some these programs. But now we have very new step in application of this knowledge, such that we have a lot of data, and we need to use in right way this data. One of the problems with data, we can generate some new data, and for this reason we can change real world through this data. And application of a program on the basis this not correct data will came us with some difficult, catastrophic problems, exactly. And for this reason, we need to study some very important problem about what we would like to do, and to construct some formal languages for which we can describe the task what we would like to do. And after that, when we constructed program, we can recognize it's really solve this problem what we constructed in this case. And really, in the world, it was a problem about trusted programs, and trusted artificial intelligence was recognized not so long time ago. And exactly in 2018, it was this decision on UNESCO about some special World Logic Day. And it was did before the logic was basis knowledge about constructing our knowledge, about constructed our application to the world for this reason. And this day was celebrated 4 days ago, 14 January. Every year it's a special celebration, and we have a lot of conference, and exactly this conference has domain what we need to solve. What's the problem we need to solve? We can do it in the natural language, but after that we need to construct it for this ontology some mathematical theory to create on the base of mathematics some mathematical models, and in these models we describe what the task, what the question we need to solve about this object, and how we can construct a control system, automatic control system for very complicated object in this case. But you know that computer works not with all mathematics. Computer works only with digital numbers, natural numbers, and we need to reconstruct it exactly some computable part of this ontology on this step. And on this step, we need to give explanation. Huh? What we will have do in this case, and on this step, we need to solve the problem about this special logic to solve this problem about this task. And it was understood many years ago in the middle of previous century, and was started to study exactly computable models. It was started by Fröhlich-Schäfersohn, Rabin, and Russian mathematician Anatoly Maltsev about presentation, exactly computable presentation of model, and study this model in this way. It's exactly Maltsev. He was founder of mathematical logic in Siberia, in Novosibirsk, and he created very big school in mathematical logic and application of mathematical logic in automata theory, in programming, and so on. And his idea was, if we consider models, in this case we consider the model in which we have some computable set of numbers, natural numbers, like basis set, and all relation and function on this set of elements will be computable. In this case, we have recursive, or like Robert Saar suggested to name these models computable models. And some another idea was to consider constructive models. In this case, we can enumerate our models by natural number and to work with this, like Gödel numbers in the theory by Gödel for models, and to construct these models. And some another colleagues, Anil Nirod, it's professor of Cornell University and director of Institute, or he was a director of Institute of Mathematics of Ministry of Defense, United States. He suggested to consider hybrid mathematics, to combine discrete mathematics and continuous mathematics, so that if we work with continuous mathematics, in this case we need to work with continuum, with, of course, real numbers, with complex number, and with function, but it's a lot of, it's not constructive elements. But we need to reproduce all this theory on the computable like. And in this area, to work together, we prepare and published 2 volumes of books, Handbook of Recursive Mathematics, about all this problem connected with decidability and possibility to construct some problem. So one of the problems in that time, it was exactly in 90s, was discussed about some fuel in the plane. We box with fuel with organized to use this, such that if we take fuel from one box and after that we destroy for plane to fly. And it was one of the problem. It's simple problem on the first level, but nevertheless, a lot of hybrid problems connected. We have some moving of complicated object, but we need to use some programs to control this system. But for this reason, we need to use discrete method for control of continuous movement. And some another work in this area. And exactly, it's a lot of problems which we need to solve. It's about what we can construct this ontology and combine the continuous mathematics and discrete mathematics, and what's the relation between these. Why we can to describe the properties of program and to give some accuracy. And a lot of problems connected with these systems. And in the middle of the last previous century, it was started exactly machine learning system. It was started at first very easy program. If we have some program and we can compute and to know some values of this function for initial segment, can be produced from this knowledge about this finite part of function, all functions, the program which computes this function. And exactly it's very was learning a lot of application. It's Bardeen, Bloom work in this area. And first of all, it was noted that there are some classes for which we cannot solve this problem, such that it's very complicated problem to compute, and it's not. It was some more weak definition to recognize not function but algorithmic process for this function, to change from step by step, but on the limit to construct this function. But it's not possible too for some version. Some it was exactly solved by Case, Smith, Bardeen for different classes. And another problem was presented by Frank Stefan from Singapore University, and with Professor Ambaspis and Badaev, Ambaspis from Germany, Badaev from Kazakhstan. We solved this problem and constructed this problem about existence machine learning function for the text, for computable text, and it's constructed very good class of this text, but it's not was not possible to solve this problem. And there are new problems here about the text which has some mistake, and we change this text. Can we recognize this changing of this text in this? One of the first problem, it's constructed exactly constructive models for different theories, and exactly computable, but not only computable, but computable with some bounded complexity, such that if we have to wait very long time, it's not work for control system. And some mathematics for these problems was suggested by academician Yershov. It's in his book Definability and Computability General, and for functionals, some topological methods to construct a computable functional was presented in this new book, Topology for Discrete Mathematics by Yuri Yershov, and in this in the last year he was awarded by Lobachevsky Prize for this book. And idea, what about constructed? It's idea produced from Moskovakis and some another mathematician to constructed computability for arbitrary models, not only countable models, but for arbitrary models. And it's the theory of computability was suggested by Yershov, and we did this theory for some special, and we consider the superset for arbitrary set. We can consider superset from the list of elements, finite list, and list of lists, and so on. And on this basis, it's possible to define it, general computability, and to find this connection between discrete and continuous mathematics and solve this problem. I will take its not right direction. And one of these problem is connected. Can we solve the problem about complexity, this computation? And with Andrei Nechosov, we constructed some polynomial variant for Gandhi theorem. For inductive definition, it's possible to construct it bound and to find polynomial computability in this case. And it's very important part to solve this problem about, and I take, and second problem is about constructing computable representation for our system with polynomial complexity. If we know polynomial complexity, in this case, we can solve the problem about guarantee the accuracy for algorithm, such that it was a Godunov problem about constructing. He noted that if we used usual computational methods, we can have different result with small difference in initial data. And it's problem that if we use this approximation of differential equation, in this case, we cannot compute exactly the level of explicitly difference between real decision and this computational level. And it's a second problem for this accuracy. But it's interesting, but it's a new idea. Not we have not realization in practice this idea. It was constructed for the field of algebraic real numbers, some polynomial presentation. And if we used this polynomial representation, we can compute the level of difference and to control accuracy of this algorithm through this. And it's Pavel Alayev and Viktor Selivanov constructed this presentation. But in this presentation we can. But the level of complexity, nevertheless, very high. And one of the problems, it's constructed for this algebraic real field of algebraic real numbers, more low level of polynomial complexity. And if we will did it, in this case, we can construct this problem. Some what's the problem? Yes, about the third problem. It's very important problem now with control system for programming system for big complex for which we need to construct it for rocket or something like this, for plane. We need to control different blocks in this programming. We need to know about the time, what time we will need to have result and to do some control decision about this system. And one of the problem is to construct it guarantee time for work on these blocks. And not only all programs, but for different blocks. If we don't guarantee this, we can compute very long time and don't do what we need to do with this complex and destroy big system from the small mistake in these blocks. And one of idea to use this, if we take our language with polynomial complexity, in this case we can control on all level, on any blocks, the time. But of course we know some upper bound. But if we can compute this upper bound and our system don't have this from our technical task that we need more small time. It means that we need to construct a new program which will do with this guarantee complexity of this number. And it's very important part in the artificial intellect, what we will use in this case. And it's exactly about what is туда пошел. And it's some idea to use this system, what we construct, this control system for our telecommunication. and telecommunication and control system for some application with many people who work with this system. And in this case, we can construct it through solving of this basis problem and ontology. We can solve this problem very effective. And Vitaly Gumirov, he was our student, but after that he started to work in some company which has some connection with Chinese people to create some special program for this control system. And our system is basis method can used to solve many problems, and it's important that we can use computability with oracles. If we can use with oracles, we can use programs constructed from machine learning, but we have some probability that for some problem this program will be work correctly. And we, like Oracle, we used this program, and to we can compute the degree of safety of this program for solving this problem. And I think it's very important to use such that in machine learning now, in the linguistic machine learning, what we have decision, we have really a lot of mistakes, such that we check some solution from machine learning. It's sometimes against logic, and it's not correct decision from linguistic data. But linguistic data is very broad, and not any time it's correct data, and a lot of, if we consider the usual decision from politicians, and a lot of speeches has a lot of mistake, logical mistake in the given information, and declare some law which really against the. Thank you very much.
Thank you, Sergey. Very nice talk. I don't think, I don't know, I can use this, okay? How many people can fully understand? Okay. Question, so your system, Sigma language, basically guarantee two things: accuracy and the time, right? So, but the requirement is you require the function be polynomial.
Polynomial means that the time what we need we can compute the
Microphone, okay.
we can compute from the program exactly the for initial data. We can compute the time what will have result from this program for by polynomial from data, and it's very quickly we have time, but if we used usual program, sometimes it's maybe work many years before give this answer. Sometimes it's maybe give our throws 15 second. But it's not enough to take correct moving. Our car will go from
Okay. Due to the time, so we will stop this discussion. Thank you.
Thank you very much.
Okay. Thanks.